Good day, everyone. Let us try to solve this geometry problem from Iran, courtesy of the Iranian International Geometry Olympiad. And here is the problem. Given this grid right here, a man wants to move from point A to point B. He cannot walk inside the orange areas, but he is free to move in any direction inside the white areas, including the grids. Find the length of the shortest path between A and B. Now, the problem is asking us to find the shortest possible path coming from A going to B. Now, before we can find the length of the shortest path, we need first to identify as to what direction of the movement can we determine the shortest path. Now, based on the conditions given in the problem, the man can move up or down as long as it is inside the white areas. Now, if the man decides to go up, one possible path that he could take is this one. Now, as you can see, although initially the man went up, at some point he will move down due to the fact that B is in a position lower than point A. Now, the same thing will happen if the man chooses this path, which we traced in red. Now, therefore, if the man initially moves up, it is always inevitable that he will move down to reach B. Now, knowing this situation, we can tell that the man can pass through any of these grids that are dotted in blue. And all in all, if we're going to count these grids with blue dots, there are 115 of them. That means the man could possibly pass through all of these 115 grids if he chose to move up in order for him to reach at point B. Now, should the man decides to move down, we can see that by the same analysis we used to previously determine the path if the man moves up, that these grids dotted in red are the possible grids where the man could pass. And if we're going to count them, there are 47 possible grids. Now, comparing the number of grids, we can tell that the shortest path lies along the downward route. So let us focus here, this one here. Now, as you can see, along this region, this one, the shortest path lies along this diagonal here, because if you draw this diagonal, there are only 3 possible grids that are being passed through out of the 9 possible grids. Now, using the same analysis, we can also say that this will be the shortest path along this region because it only takes 4 grids right here. This one here. And then, same thing with this part here. Now, then we have this 2 straight segments here because we have to pass the border. This one here, notice that they're along the border. We need to pass along the border because passing along them will lead to the shortest path as well. Now, in this case, we just found the shortest path. We have 3 diagonals and 2 short paths. Now, to find the measure of the entire path, we will determine the measure of each segment. Now, the shortest path problems are one of the most basic and practical application of the right triangle because its hypotenuse is the shortest distance from the endpoints of the legs. Therefore, since diagonal segments represent a part of the shortest path, we can consider them as the hypotenuse of a right triangle. So we draw the legs of the right triangles like this. So we have that one. Now, counting the grids, we can find the measure of each legs. You have that one. Now, since the path represents the hypotenuse, we use the Pythagorean theorem to find their legs. So for this one here, we have 3 square root of 2, For this one, we use the Pythagorean theorem. We end up with 5. And lastly, for this one here, using the Pythagorean theorem, we have 2 square root of 2. Then, take note, we have these 2 short segments here. It's just comprised of one grid. Now, we add all of this in order for us to find the measure of the path. We have 1 plus 1 plus 5 plus 2 square root of 2 plus 3 square root of 2. This will give us 7 plus 5 square root of 2. So this is now the length of the path and the problem is solved. So that's it for this video. Please don't forget to like and subscribe to our channel for more challenging geometry problems. Thank you so much. Enjoy learning.